In this video, we are going to start with differentiation. Let's take into consideration a function y, that is our f of x. Now if we need to find slope of this particular function at a particular given point, let's take into consideration a graph of our fx for x. This becomes our fx, and if I consider a particular point x, that is we need to find slope for. So if I need to find slope at this particular point, and I consider this particular value x, and here I am saying x plus h, which will give me f of x here, and this value becomes f of x plus h. Now if I am trying to find slope, what I am essentially doing is I am making a straight line that joins these 2 points, and I am finding slope for that. So slope is nothing but change in y with respect to change in x. That gives us y2 minus y1 upon x2 minus x1, or in this case it will be f of x plus h minus f of x upon x plus h minus x, or we can just write here h. So this becomes our slope. Now the problem with this is it is just an approximate slope. It is not giving me exact slope value at this particular point, but it is giving me an approximate slope for this particular line. Now if I want to be more precise, what I can do is I can go much more closer. I can find slope from this point to this point, but that will again be an approximation. The closest I can go is where I can assume that the difference between these 2 points is almost negligible, or we say that our h is tending towards 0. We say our limit, we take limit when we are almost reaching 0. So we say limit our h is tending towards 0, our change in y with respect to change in x can be written as dy by dx. This is what differentiation is all about. We are trying to find slope at a single point. So for that we take very small values around it. One will be x, the other will be x plus h, where h is almost equal to 0. That means they are literally the same point. And for that we get that the slope, that is going to be our dy by dx, will be limit h is almost equal to 0, f of x plus h minus f of x upon h. This way of finding the slope or doing the differentiation is called as the first principle. Now let's try to find a particular differentiation. If I say my y is equals to x square, or you can say my fx is my x square, if I need to find differentiation for that, I will say my limit h tending towards 0, f of x plus h minus f of x upon h will give me limit h is tending towards 0, x square, we'll have x plus h whole square minus x square upon h. If I expand this value, I get x square plus 2hx plus h square minus x square upon h. That will be nothing but 2hx plus h square by h. If we divide by h, we are left with 2x plus h. Now whenever we are using limits, what we are trying to do is we are trying to avoid an infinite value. Now when my h was in the denominator, and if I put my h being equal to 0, because it is almost equal to 0. So if I put h is equals to 0 and I have h in the denominator, I get an infinite value. So we are trying to avoid that. So as soon as my h now is not in the denominator, what I can do is I can put my h equal to 0. If I put h equal to 0 here, I get 2x. So we get the differentiation of our x square with respect to x will give us 2x value. This is how we solve or find different formulas of differentiation using our first principle. Now let's take into consideration if I have a formula y is equals to 3x square plus 2x plus 4, any function, and if I need to find the differentiation using our first principle, I'll say my dy by dx will be limit h tending towards 0, where I'll get 3, I'll put instead of x first x plus h, so I get x plus h whole square plus 2 x plus h plus 4, and then minus for the same I will just put x, so I'll get 3x square plus 2x plus 4, the whole divided by h. So for this, again you should expand. We can clearly see this plus 4 and this minus 4 will cancel out. This plus 2x, this minus 2x will cancel out. So we'll skip writing them. I'll say I'll get 3 x square plus 2hx plus h square 2h minus 3x square upon h. If we remove our 3x square, we'll get, and I'll just multiply this 3, we'll get 6hx plus h square plus 2h minus nothing, upon h. Now we can remove our h and divide by h, we'll get limit, our h is tending towards 0, we get 6x plus h plus 2. We can substitute our h value because now we do not have h in the denominator, and we'll get our 6x plus 2. So this is how we'll solve using our first principle. Now definitely in our course we do not need our first principle. This is just a way of showing how do we find different formulas. In actuality, we'll directly use some formulas. So let's say if I have some functions, what will be the differentiation of those functions with respect to our x? So if I have a function x raised to n, we get differentiation n times x raised to n minus 1. If we have e raised to x, we get e raised to x. If we have a raised to x, we get a raised to x log of a, and if we have some constant, so we get 0. So differentiation of a constant is 0. So these are the main 4 formulas. One more, log If I have log x, then the differentiation is 1 by x. So these are the basic 5 formulas that we are going to use directly, and we are going to solve for any kind of differentiation we require. Now let's take into consideration if I have y is equals to x raised to 5. So if I differentiate, my dy by dx will be x raised to 5, that is my x raised to n. I should get n times x raised to n minus 1. That will give me 5 times x raised to 4. So this is how we can use our direct formulas to differentiate. If I had y is equals to, let's say, 10 raised to x, I'll get my differentiation dy by dx. Here we'll get a raised to x, that is nothing but our 10 raised to x. So I'll say it is 10 raised to x log of 10. We can use these formulas anytime we want directly to differentiate our values. Now whenever a constant is multiplied to our function, let's say if I had y is equals to 10 times x raised to 7. So what we can do is we can take our constant outside our differentiation. So my dy by dx is going to be, I can say, differentiation of 10 x raised to 7 dx. I can write this as 10 times d x raised to 7 dx. That will give me 10 into 7 x raised to 6. So that is 70 x raised to 6. Other than that, if I have addition or subtraction, let's say if my y is 3x square plus 4x plus 2. What we can do is we can separate. I'll take one addition and I'll take one subtraction. Let's say this. So we can give individual differentiation to all of these values. I can say differentiation dy by dx will be nothing but differentiation of our 3x square with respect to x plus differentiation of 4x with respect to x plus differentiation of 2 with respect to x. Then we can solve them individually. Now 3 is constant, that will come out. Differentiation of x square should be according to our x raised to n. So I should get 3 times 2x, and 4x, 4 again constant, comes out. Differentiation of x, you can clearly see, again you can do it x raised to with respect to x raised to n, or you can just say it will be our dx by dx, that should be equal to 1. So we'll get 4. And differentiation of a constant, differentiation of 2 constant should always be 0. So plus 0. So we are getting 6x plus 4. This becomes our differentiation. So for properties, if I have some constant multiplied to a function of x and I differentiate with respect to x, I should get constant outside and just differentiation of that function with respect to x. The second property that we would say, that if I have two functions f of x plus or minus g of x, if I differentiate this with respect to x, I should get individual differentiation plus or minus So I can separate my differentiation when I have addition or subtraction in between, and I can take constants out if the constants are multiply. Let's take a few examples. Now for a first, we say y is equals to 3 by x raised to 5. I can write this as 3 times x raised to minus 5. When I differentiate, I'll get my dy by dx. 3 is constant, so I'll get differentiation of x raised to minus 5 with respect to x. And we can use our x raised to n formula to differentiate that. So we are going to get n, that is our minus 5. So minus 5 x raised to, we'll get n minus 1, that becomes minus 5 minus 1, that will be minus 15 x raised to minus 6, or you can write it as 15 by x raised to 6. Now for the second one, what we can do is we can just open the bracket. We are going to get 2x square plus 6x minus 3 minus x minus 3. You can say this is 2x square plus 5x minus 3. Now when we differentiate, we'll write our dy by dx. Now dy by dx, we know that whenever we have addition or subtraction, we can separate our differentiation and constants can come out. So I can write this as 2 times differentiation of x square with respect to x plus 5 times differentiation of x with respect to x minus differentiation of 3 with respect to x. That just gives me differentiation of x square according to our x raised to n. I'll get 2 into 2x. Differentiation of x will just give me 1. So I'll get 5. And differentiation of constant will just give me 0. So I'm getting 4x plus 5. For our third one, log of x raised to 9. What we can do is we can say our log of x raised to 9 can be written as 9 times log of x, which is the property of log. Then when we differentiate, we'll get our dy by dx is equals to 9 constant differentiation of log x with respect to x. So we should get nothing but 9 by x, because differentiation of log x gives us 1 by x. Then fourth one, if we differentiate our y with respect to x, we know we can give individual differentiation when we have addition and subtraction. So I can write this as differentiation of x raised to 5 with respect to x, then differentiation of 5 raised to x, and minus differentiation of e raised to x with respect to x. So I have given individual differentiation. Then x raised to 5, differentiation of x raised to 5 will happen again as differentiation of x raised to n. So I'll get 5 times x raised to 4 plus 5 raised to x is our a raised to x. So we get 5 raised to x log of 5 and minus e raised to x has differentiation e raised to x, we'll get this. Now remember, whatever log we are using, it is always log to the base e. So anytime you see log without any base, it is always log to the base e. So our log to the base e can also be written as ln x, that is nothing but natural log, and that is nothing but log to the base e. So whenever we are writing log, we are writing it as log to the base e. Now we'll take into consideration what happens if we have two functions multiplied together. Let's take two functions u and v that are functions of x that are multiplied together. Now when we differentiate this, we get, first we take second function constant, differentiate our first function, plus we take our first function constant and differentiate our second function. We can write this as u dash v plus v dash u. So this is differentiation of first into second plus differentiation of second into the first. Now, while we were solving, we solved this particular question where we had y is equals to x plus 3 2x minus 1, and we got our final answer as 4x plus 5. Now we expanded this, but we can solve it using this particular example as well, this particular multiplication as well. So we'll consider our differentiation of y with respect to x. What we'll say this is our first function, this is our second function. So I can take my second function constant, that is my 2x minus 1, and differentiate my first function. So differentiation of x plus 3 with respect to x, plus I can take my first function constant, that will be my x plus 3, and differentiate my second function, that is 2x minus 1. So that will give us differentiation of this, differentiation of x should be 1 and differentiation of 3 should be 0. So I'll get just 1 and plus x plus 3, and differentiation of 2x should give me 2 because 2 is just constant, and differentiation of 1 will be 1. Sorry, differentiation of x will be 1 and differentiation of 1 becomes 0. So finally we are getting 4x minus 1 plus 6, or you can say plus 5. So we get the same answer. We'll take another example. Let's say that our y is equals to e raised to 5 e raised to x into x raised to 5. Now how do we solve this? We'll say differentiation of y with respect to x should be first differentiation of 1 taking the second constant. So x raised to 5 constant, differentiation of e raised to x with respect to x, plus we'll have second constant, or you can say first constant, and differentiation of second, x raised to 5 with respect to x. This will give us differentiation of e raised to x is e raised to x, and differentiation of x raised to 5 will give us 5 x raised to 4. So we get e raised to x raised to 5 plus 5 times x raised to 4. Let's take a few more examples. Let's say I have y as x raised to 7 log of x. Now here when I differentiate my y with respect to my x, I will say take log x constant, differentiate x raised to 7 with respect to x, plus take x raised to 7 constant, differentiation of log x with respect to x. So we'll get log x into 7 times x raised to 6 plus x raised to 7 constant, and log x will give us 1 by x. So that becomes 7 x raised to 6 log x plus x raised to 6. You can take x raised to 6 and you can write it in that ways as well. So this is another way of differentiating when we have two functions multiplied together. Now what happens if we have three functions multiplied together? So if I have, let's say, e raised to x into log x and also x raised to 5. I have these three functions multiplied together. So what will we do is, we'll just take two constants and differentiate one. So we'll take x raised to 5 log x constant and we'll differentiate e raised to x, plus now we'll take x raised to 5 and e raised to x constant and we'll differentiate log x, plus we'll say we'll take e raised to x and log x constant and we'll differentiate x raised to 5. So we are getting x raised to 5 log x into e raised to x, plus here log x will give us 1 by x, so x raised to 5 e raised to x into 1 by x, plus we'll get e raised to x log x and we'll get 5 into x raised to 4. So this is how we can actually find differentiation of any number of multiplied functions by differentiating one and keeping the others constant and then adding all such possible values. Now we'll also consider what happens if we have two functions divided together. So if we have u by v, what happens then? So I can take differentiation of u by v with respect to x and I can write this as differentiation of u into v raised to minus 1. Let's directly see the formula. I'll explain that later, how do we get that, but we'll just see the formula first. So the formula we get is, we say we keep v constant, we differentiate u, then minus we keep u constant, we differentiate v upon v square. So you can write this as u dash v minus v dash u upon v square. Let's take y as our, let's say, log x by x raised to 5. So for that, when we are differentiating, we'll say that first we'll differentiate our numerator, so and keeping our denominator constant. So x raised to 5 differentiation of log x minus, we'll keep our numerator constant, so log x differentiation of x raised to 5. This divided by denominator square, so x raised to 5 square. So we are going to get x raised to 5 into 1 by x minus log x into 5 times x raised to 4, this divided by x raised to 10. I can take x raised to 4 common from both of them, get 1 minus 5 times log x divided by x raised to 10, or you can say you will have 1 minus 5 times log x by x raised to 6. So we can find our functions multiplied or functions divided. So I'll write down our formulas again. If we have two functions multiplied, so differentiation of u into v with respect to x will give us u dash v plus v dash u, and if we have differentiation of u by v we get u dash v minus v dash u divided by v square. Now we'll solve some sums. Let's take into consideration these examples. For the first one, we can clearly see we have two functions multiplied, x square and log x. So we'll use our multiplication formula and we'll say differentiation of y with respect to x is going to be log x, differentiation of x square with respect to x plus x square differentiation of log x with respect to x. So here we are going to get 2x, that was our differentiation of x square, log x plus, for log x differentiation becomes 1 by x, so I get x square into 1 by x, or you can write this as x common 2 log x plus 1. Now for the second one, we'll say our dy by dx will be again multiplication, so we will take e raised to x constant, differentiate x cube with respect to x, and plus we will take e raised to we'll take x cube as constant and differentiate e raised to x with respect to x. This will be 3x e raised to x plus 3x square plus x cube e raised to x. For the third one, we'll say our dy by dx should be, this is u by v, so in that first we differentiate our u, that will be e raised to x, keeping v constant. So we'll get log x, differentiation of e raised to x with respect to x, minus, we'll differentiate our v and keep u constant. So e raised to x constant, differentiation of log x with respect to x, and then we divide whole by v square, so we get log x the whole square. So finally we'll get e raised to x log x minus e raised to x 1 by x whole divided by log x whole square. Then we'll do the fourth one here. For our dy by dx, fourth one we can see it is x cube by 7x. So again we'll differentiate our u and take v constant, 7 raised to x, differentiation of x cube with respect to x, minus, we'll keep our x cube constant, differentiation of 7x, 7 raised to x with respect to x, upon, we'll have 7 raised to x the whole square. That will be our 3x square 7 raised to x minus x cube 7 raised to x log of 7 upon 7 raised to 2x. So in this manner you can use your multiplication function, or you can say multiplication formula, or you can use your division formula when we have two functions multiplied or divided together.